what we're going to do, in this case, what you will hopefully notice about these is that all of my factors, instead of being like before, they just looked like this. We factored them and they just looked like that. They didn't have any equal sign. It was just a trinomial. It was an expression. Well, now they're equal to something. So now, since they're equal to something, I can actually solve and figure out what that thing is. So we're going to start these off just like we do anything else, by factoring. The first thing, you always have to, so it must be equal to 0 first. So the first thing you do is you make sure that it's set equal to 0. So like, for example, there was a problem on yesterday's homework where it said, I think it said x squared plus 9 equals 81. We wouldn't be able to use factoring for this strategy. It might have been x squared minus 9. I think it was x squared minus 9 equals 81. We would have to move that 81. We would have to get it set equal to 0 before we could use factoring to solve this problem. Okay? So it has to be equal to 0 first. That's like the first rule. Okay? And it says that right here. It must be set equal to 0 before you can factor or solve. Okay? But I felt like that bears repeating because it's so important. Okay? So this one is set equal to 0. So I'm going to factor it like I would normally. First thing I do is I look for a GCF. There isn't one. So I'm going to put it in the box and start factoring it. Okay, A is 3, B is 13, C is negative 10. Okay, 3 times negative 10 is negative 30, and B is 13. So they have to multiply to negative 30 and add up to 13. Well, that's going to be 15 times negative 2. How do I know that? I just do. But if you need to, you can always make a table, okay? So 15 times negative 2 is negative 30. 15 plus negative 2 is 13. So those are the two factors I want. 15x goes here, and negative 2x goes here. Again, does it matter where it goes? No. I'm sorry. I'm going to erase this just because I don't have room, okay? But you would normally leave it there. Okay, now I'm going to start taking out my GCF. The GCF here is 3x minus 2. Up here it's x plus 5. So my factors are 3x minus 2 times x plus 5. Now, this is where it gets different. And this is the only thing that's different. Before, it wasn't set equal to anything. And now it is. So I keep it equal to 0. We have this thing called the zero product property. I'm going to take a quick little detour. We're going to talk about the zero product property. Okay, so what the zero product property says is it says that if you have two numbers, so let's say I have like x times y equals 0. All right, and I don't know what those two numbers represent. One of them has to be 0, but since I don't know which one, I have to kind of like see what it would be if either one of them was. Like, for example, let's say I had 3 times x equals 0. Well, then what does x have to be? X has to be 0. Well, what if I had x times 5 equals 0? Well, then x has to be 0. If I multiply anything by 0, anything that equals 0 means at least one of the terms had to be 0. So what I have to do is I have to assume that I have to see what would happen if x was 0, what would happen if y was 0. So let me show you what that's going to look like over here. I have two possibilities here, okay? It's possible that this whole term is 0, because if this whole term was 0, right, then this times this would equal 0, because anything times 0 equals 0, right? So if this one was 0, then I could solve then x would have to be 2/3. So let's see what would happen. 3 times 2/3 is 2. 2 minus 2 is 0. So then this one works out to be 0. 2/3 plus 5 is 5 and 2/3. 0 times 5 and 2/3 is 0. So 0 could be 2/3. All right? Now, likewise, if instead this term was 0, so like if this was 0, this times 0 is 0. So also, that whole term could be 0, all right? And then I subtract 5 from both sides to isolate my x, and I get x equals -5, okay? All this means is that I have two possibilities. I have two x values that could make this statement true. If I substitute in, and let's just do it, okay? Okay, okay, if I look here and I do 3, oh, there's going to be a lot of parentheses, 3 times, let's look at the first one, 2/3 minus 2. Again, all I'm doing is substituting in for x, okay, times 2/3 plus 5, I get 0. Okay, let's try the other one. Let's do 3 times -5 minus 2 times -5 plus 5. I get, oh, whoopsie, sorry about that, I messed up. No. Oh, I see what I did wrong. I forgot to put the parentheses in the front. Sorry about that. Oopsie. Okay, now I get 0 for both of these, okay? So since I get 0 for both of these, that means both of these values are true, and both of these values make my equation true. So that means my two x values that make y 0 are 2/3 and -5, okay?